All right. What we're going to do is we're going to do a molar volume of a gas lab tomorrow. Two objectives. You could find the values, everything else in the ideal gas law except R, which will allow you to calculate R, the 0.0821, if you have the PVT and the number of moles. The other thing is you can experimentally determine the volume of 1 mole of gas, which we already know is 22.4 liters at STP. But if we find it at a different temperature and pressure, we can plug it in and solve for it. That's the whole point of this lab. So when you're prepping your lab notebook, the first thing that you should do is you should make sure that you have in the upper part the title of the experiment, molar volume of a gas, the date. Then you would have the objectives. You should have the objectives clearly labeled and know why you're doing a lab every time you step into a classroom. What we're going to do during this lab is basically we're going to fill the gas collecting tube, which looks like a giant long test tube, which looks like this right here. And what we're going to do is a couple key things. You're going to put a certain amount of acid. You need to know exactly how much acid. It's going to be 6 molar acid is going to go in there that you're going to use a graduated cylinder to measure. Then what you're going to do is you're going to fill the rest of the tube with water. So you're going to fill the rest of the gigantic tube with water. And then you're going to take a ball of magnesium. You're going to take a little piece of magnesium ribbon. You're going to fold it up to like an accordion or scrunch it up into a ball. And then you're going to take copper wire and you're going to take that magnesium and wrap it into a tight little ball of copper and then with a little tail at the end of it. And what that's going to do is that thing is going to be inserted into your tube. Obviously it's larger than that. The picture's a little too large. I wonder if I could scale that down. You're going to take that thing that you create, stick that into the tube, and then what you're going to do is you're going to bend it over and put a stopper in there, stopper with a hole in there. So what you're going to do is you can basically have acid, water, and magnesium. Well, we know HCl, acid, and magnesium will actually react and cause a single replacement reaction. The hardest part of this lab is actually wrapping the copper and magnesium, believe it or not, getting it so it fits within the tube. So you have to make sure the copper cage that you wrap it in fits inside the tube and that you can put the stopper on there. Then you're going to flip it over. You flip this thing over, you're going to take the tube, you're going to flip it over, you're going to submerge it in a beaker of water, and what's going to happen is gas is going to be created because the acid will sink down and react with the magnesium, creating HCl plus Mg is going to create what? It's going to create hydrogen gas plus MgCl2. So this is the gas we're focused on. We're going to create hydrogen gas. The reaction is going to be occurring down here. Let me highlight it in green. The reaction is going to be occurring here, and the gas bubbles are going to be traveling this way. As the gas bubbles go up, they're going to displace the water, so they're going to shove the water level going down this way. We'll be able to read the volume in the tube. That's why gas tubes are designed, is to read the volume. So then what you're going to do is you'll transfer it into a giant graduated cylinder. You'll make sure that the water level inside and outside the tube is equal. The reason we do that is you basically will either raise this up or push it down to adjust to make sure that the water levels are equal, so you know that the pressure inside the tube will be equal to the pressure outside, which we will measure with a barometer. So you'll be able to do that. When the water levels are equal, it means the force pushing down on either level is equal, so that's how we find the pressure. So you're going to get the pressure in this lab. Your p-value is going to come from barometric pressure that we're going to read off the sensor I have on the computer, and it'll tell us barometric pressure. Then, how do you find the temperature of the gas? You're going to measure the temperature of the water of the beaker is going to be the same temperature as when the reaction's done as the temperature of the gas inside, because it's happening over water. It'll be the same temperature. So the temperature, you're going to use a thermometer to measure the temperature in the beaker. How do you find volume? After you correct the water level in this gas collecting tube right here, after you correct it, you're going to read the volume off the tube. The tube is graduated, so you have your P from the pressure. We're going to read that off the computer because the atmospheric pressure will be equal inside when the water levels are equal. So you got our P. T comes from the water in the beaker. Volume is going to come from the side of the tube. The other thing you need is N, number of moles. Well, before we start, your piece of magnesium, you're going to weigh out your piece of magnesium, and you'll know how many grams it is, so you'll be able to convert it into moles. one of the things I ask you to do is modify the procedure. When you modify a procedure, you simplify it. Basically, you would write down that you need 4.0 centimeter ribbon of magnesium, sandpaper, and copper. So you just get those three things. Shorten the sentences is all you're doing. You're going to sand magnesium. Make sure you don't top, so place it on a paper towel. Then you're going to weigh the magnesium. So shorten it down. Ideally, what you're doing is reading it and cutting it down so that you fully understand what you're going to do during a lab. If you copy it word for word, it won't make complete sense to you. You're going to wrap the magnesium, round copper wire. I kind of showed you a picture of that. So you're going to do it in a tight ball so it can fit inside the actual tube, the gas collection tube that we're going to use. You'll obtain a gas collection tube from a stock room. I'll get you one of those. Then you're going to get your acid. How much acid do you have to weigh out or measure out? 10 milliliters. Whenever you are going to work in a lab, you should always know the exact quantity. You would highlight it in your procedure. 10 milliliters of HCl. Underline it, double underline it, so you know the amounts that you're supposed to be doing. How far are you supposed to put it down? 2 centimeters from the top. So the key ideas or the key things in your lab procedure, that's what a modified lab procedure is. Finally, data. We are only going to do one trial in the lab tomorrow because there's not enough time to do two. But what you're going to do is from another lab group in class, you're going to get the data from another lab group. That'll count as trial 2. Key things that you have to get, data points are mass, molarity is off the side of the bottle, volume, you're going to read that. That's a data point you have to, actually, you will measure the volume of the hydrochloric acid, but I thought that was the gas. So you get that from the volume is from your graduated cylinder. Volume of the H2 gas collected is a key data point. Temperature, you need to know how that you get from the beaker. Temperature of the water in the bucket is the same. Vapor pressure of water, we'll get that from a chart because we want the dry gas. And atmospheric pressure will be the same as the pressure inside as long as you level the, if the two levels inside and outside the tube are equal, it'll be equal to atmospheric pressure. When you walk in tomorrow, key things you need. Your objectives need to be in your lab book. Your modified procedure should be written out, and this data table should be in your lab notebook. Use a ruler. Don't do it sloppy. It should be nice and neat. If you wanted to print this out and cut and paste it into your lab notebook, you could do that, but make sure it's pasted completely down. Have a good evening. There's no other homework. All you have to do is just basically make sure you get your lab prep for your lab notebook. All right? Have a good evening. Stay out of trouble.